Hey guys, so annuities now we have future and present annuities, but by annuity we simply mean okay, for annuities we mean there are equal amounts of payments that we are making, right? And now what separates these annuities, we have future and present, right? And yeah, for this video, I'll just specifically talk about future annuities. So, future annuities, like we have already said, you are making equal payments every month, right? But for future annuities, with the idea that you are saving towards something. Say, for an example, you're doing grade 12 right now, and you want to go to university next year, and at home, you guys don't have money. So, you find a way of actually raising money, and you're gonna get a certain amount of money monthly, right, from the project that you have. And you decide, okay, I'm gonna put this much amount of money every month, right? At the end of every month, I'm gonna put this amount of money, no questions asked, into a savings account, right? And so forth and so forth and so forth, for like, I don't know, until for the time, maybe say a year, a full year, like 12 months, right? And you want to see how much you're gonna end up with. We use future annuities, right, to deal with that, future value annuities. And yeah, but like, just anything that involves you putting money into a savings account, all right, for a particular goal at the end. We are not paying any loan here. For loans, we're gonna talk about the present annuities. For here, you putting your money into account every month or every year or every other interval. Yeah, yeah. So what we will be calculating, it's just gonna be around those lines. We're gonna calculate how much money you will have at this at the end of the period. How much money should you put in every month to end up with this much at the end of the month? How long should you invest your money if you are putting this much every month, and you'll be having this much at the end of the period? How long will that take? Yeah, one. So we're going to deal with that calculations now. Cool. So far from grade 11, you guys learned about timeline, né? Yeah, you guys are learned about timeline, so this is gonna be a reminder, or yeah, refresher for the timeline. So at the end of each year, for 4 years, Gobox deposit 500 into an investment account, right? Yeah, so Gobox saves 500 rand into a savings account, and if the interest rate on the account is 10% per annum compounded yearly, determine the value of the investment at the end of 4 years, right? So cool. So this person, let's draw our timeline first. Uh, 2, 3. Cool. So this is T0, T1, T2, T3, T4. So they're saying that at the end of each year, he deposits 500 rand. So this is the beginning of year one, and this is the end of year one. So there will be some money coming in. End of year two, money coming in. End of year three, money coming in. End of year four, money coming in. Right? And now we have to calculate how much money this dude would have made, right, during that whole period. Cool. So one of the formulas that I preferred, it was just making the calculation step by step. Yeah, well, so what we can do, actually, we can do this now. So let's do it step by step. This money here is going to be in the account. So look, we were not told about any amount of money, right, that we put in at the beginning, or any amount that was even in the account already. So you can just say on your formula, A equals to P, sorry, on this formula, if you substitute P equals to 0 here, because we are not told of the money that's already in the account or money that has been put in at the beginning, right, of this 4-year period. We were not told anything like that, so you can just put 0 for this 1 year, and then you're gonna end up with 0. So let's ignore that, right? What we can focus on is these other deposits. So let's look. This one, our dude invest, of course, the formula is this, ne? This is the formula that you guys know. So our guy invests 500 rand. This 500 rand is gonna be in the account in the account for how many years? Year 1, year 2, year 3, right? So we have A being, let me say A1, it's gonna be 500 into 1 plus I, which is 10%, so 0.1, right, to the power of n, which is gonna be 3. All right, cool. Let's forget about it for now. Calculate A2, ne? So A2 is just for this 500 rand. This 500 rand will be in the account for year 1, year 2. So that means its value, or the interest it would have gained would be, the accumulated amount will be this, because it's going to be in the account for 1, 2, so 2 years, ne? Let's do the third one. So A3 is 500, 1 plus 0 0.1, and this 500 will be in the account for just a year, right? And we have A4 is just gonna be 500 there, or you can just say 1 plus 0 0.1 to the power of 0, right? You can say that, but yeah. So now that we have all our values, right, we're gonna add them, of course, as expected, but I want us to add them in this order. We're gonna start from A4 up until the last one, up until A1, right? Cool. So we add them, all of them, to say AT will be all of them added. Yeah, from A4 to A1, right? Cool. You will see the reason why I'm doing that later on. Cool. So what can we say? Perhaps let me find the value here. Allow me to just remove this and get more space. Now I just calculate 500. In fact, look, ne? Here it's just math, ne? So I'm gonna take 500 days, 500 in each term. I'm gonna say 500 into, then I'll start adding days 1 plus days 1.1, right, plus 1.1 squared plus 1.1 to the power of 3, right, and that'll be it. Yeah, this was just to not do a lot of inputting there in the calculator. So we're getting 2,320 and 50 cents. And with what we have done now, I want us to do this. When you look at 18, 80 is a series. Right, it is a series. And as for what series is it, let's cook. So we can say we have, okay, it's a geometric series because there is a constant term, or there is a constant let me show you. So ATT T2 over T1. All right, this is just 1.1, right? And let me also say T3 over T2, or perhaps T4 over T3. So 3 and 2, everything is the same. The 500 stay cancel, laws of exponents, you're gonna just end up with this, right? And 1.1. So we have R, right? We have a constant ratio, a common constant ratio between consecutive terms, right? So that means we have a geometric, and then you will then say A is 500. Here is A because this is just 500, and then you have R, which is 1 plus 0.1, right? Or you can say it's 1.1, right? Yeah, but this writing it this way would be more helpful for later on. And then what we have, so you need A and you need R, or you need A. So when you do this, you can say S4 is gonna be, so your R is greater than 1, so we're gonna use this formula, A into Rn minus 1, R minus 1, which you have 500. You have your R, which is 1.1 to the power of 4 minus 1, and then you have 1.1 minus 1. So we put this in a calculator. Look at the value we got last time. We put this in a calculator. We have 500, 1 to the power of 4 minus 1, close, 1.1 minus 1, right? And we're getting exactly 2,300, right? This is exactly the value we got last time we did the working, right? So now this thing, let's do this. Let's delete this. We are already saying to say okay. So now if we try to substitute, make these, this is P, right, which is the value that is going to be, or the value that we make, P is the value that we're going to deposit every year, right? Or perhaps let's use X because it might be confused with principal. So X is the amount of money we are depositing at a regular interval. It could be every year or every month, but X is the amount we are is the money we are putting in the account, right, at a regular interval. And then here we have 1 plus I, which is interest. This is our I, right? And we do go to the formula. So we will say the formula says the sum of n you have Rn R minus 1. So what happens is our Sn, let's make it F for future value. It's going to be A, that is just X, and then you have R, which is 1 plus I to the power of n, right? Then you have minus 1. On this side you're going to have I plus 1, then minus 1, right? So therefore you're going to have X into 1 plus I and then this side you're going to have I, right? Because when we remove the brackets, right, 1 will subtract 1 and then you are left with I. And then in short, this will be the formula that we will use, right? F, you can even say FV for future value, right? Because this is a future value annuity and we have just derived the formula we're going to use for our calculations, right? So that being said, let's go see what examples we have. So Shelley decides to start saving money. Yeah, she decides to start saving money for her son's future. At the end of each month, she deposits 500 into an account at a Durban Trust Bank, which earns an interest of 5.96 per annum compounded quarterly, right? Cool. Determine the balance of Shelly's account after 35 years, right? So now we already know the formula we're going to use, right? It's FV equals to the amount being deposited, and then you have 1 plus I to the power of n minus 1, and then you have I, right? And then when we substitute, it's 500 that is being deposited. Then you have 1 plus the interest is gonna be 0.0596 divided by 4, because the investment is for like, or the interest, where is it, the interest is compounded quarterly. And then here you have 4 times 35, right? Then minus 1, and you have 0.0596 divided by 4. You put that in a calculator, you get your value. Zero. Cool, to the power of 4 times 35 minus 1, close, right? And the value is gonna be 4.1. So that is how much Shelly will be having at the end of 35 years. And then how much money did Shelly deposit into the account? Basically the money is gonna be it's gonna be 500, which she deposited. Let's see, she deposit each month, at the end of each month, so every month. So we have times 12 for a year, and then times 35 for 35 years, right? So 500 times 12 times 35, right? We get in the amount 210,000 rands, yeah? And to answer the question, finding the interest, right? Total deposits. So to find the interest, now interest is going to be V minus your total deposits, right? So which is 2325 minus 210, right? So, and which you get the value of 2 is gone, then you have 22,53941. So that's how much interest she has gained over the 35 year period, yeah? Cool. See the second one. So Ruth decides to save for her retirement. So she opens a savings account and immediately deposit 450 into an account, her savings account. Okay, wait, I missed something. So Ruth decides to save for retirement. She opens it and immediately deposit. Okay, cool. She immediately deposited 450 into an account. Her savings account earns an interest of 12 compounded monthly. Then she deposits 450 at the end of each month, right? What is the value of her retirement savings at the end of 35 year period? Cool. So this one, when you are reading, you can possibly be confused, like, okay, so this person deposited 450 at first, né? And then after that 450 she starts depositing 450 again, right? So how are we then gonna make these calculations? Kappa, what are they saying? What are they saying exactly? Because they say, so English can be tricky here. That's what I'm saying, but we will attack it step by step. Yeah. We will break it step by step. So we know for sure that there's an amount of money that she's going to, like, there's a 450 which she deposits immediately. All right, cool. And then this 450, then later on they say that there's a 450 which she will deposit at the end of each month, right? So we will have to account for that other one, ne? And this is how we're gonna account for it. First thing first, you know your formula, right? Right. I'm going to substitute, ne? Or perhaps let me deal with the 450 issue. So if you draw your timeline, right? If you draw your timeline and we make it be for a couple of, right? So there is a 450. So say I go and open an account right now immediately. So there is a 450 that I am depositing, right? And then later on, there's gonna be what, 450 which I will deposit at the end of each month. So at the end of first month I deposit a 450, at the end of second month 450. So yeah, so in terms of the months, this is what's going to happen. So I'm going to have 1 month. It's like you decide to deposit 450 at the end of every month, but at the beginning of the month you deposited 450. At the beginning you deposit for 450. So that means in terms of the money you would have, it's gonna be the 400 rand for the beginning and the 400 rand for the end of January, and then it will be for the 450s for the end of each month, which in total is gonna be 11 450s. Right, so that's why here you would have that 450, right, plus it's 1 plus the interest, which is 0.12, and then here it's gonna be 35 times 12. Forgot to divide by 12 here. Yeah, so times 12, ne? For each period for at the end of the month, plus the money she did put there in the beginning immediately. So this one is for this 450, right? And then this 35 times 12 is for this one, right? Cool. So now you have -1. All right. Oh no, I is 0. Yeah. So now we put our guy in a calculator to get our value. 0.012, and 0.12, yes, 12 to the power of 35 times 12 plus 1 minus 1, close bracket, 0.12 divided by 12, right? And the value we get is going to be, oh wait, here it should be 35, not 32. That was my mistake. So therefore the money she will be having is gonna be yep, 0.08, right? And yeah, there we go, 450 each month for 35 years gives you 2.9 million. Yeah. Yeah. So this is, I would say, let me call this the end. The next video, it's gonna be still about future value annuities, but it's gonna be about sinking ship. Yeah, sinking ship. But yeah, yeah, so far this is it. For more examples, we will see some in the exam questions. Alright.